Okay, I'm given that f of x is equal to the square root of x minus 6. So to find f of 10, I'm going to do the square root of 10 minus 6. Square root of 10 minus 6, well, that's just the square root of 4, and the square root of 4 is just 2. So f of 10 is equal to 2. Question says which values, and this is important, of x must be excluded from the domain of f. Now, we know that we cannot find the square root of a negative number. So in other words, we cannot have x minus 6 being less than 0. Now, if x minus 6 is less than 0, if I just add 6 to both sides of that, x is less than 6. So the values of x which must be excluded are any values of x which are less than 6. So x less than 6, that gives us the values of x which must be excluded from the domain. Okay, so here's the graph of y equals g of x, a different function. Now to find g of 2 from the graph, okay, remember y is g of x, so any values on the y-axis are g of x, and this is the x-axis. So if we want to find g of 2, we need to find 2 on the x-axis. We then travel up to the graph and then across. Probably be easier if I used a ruler here, but never mind. And we get this value here. In other words, g of 2 must equal 7. Okay, in the same way, this time we're going to find fg of 0. Now remember, fg of 0 means that we have to do g of 0 first. It means that we do g of 0, so we do this first, and then we are going to f it, if you like. So let's first of all find g of 0. So to find g of 0, we find 0 on the x-axis. We travel up until we hit the curve. In other words, g of 0 is actually this value here, which is 15. So we're now going to find, so this is 15, so we're now going to find f of 15. Now to find f of 15, we haven't got the graph of f of 15, but we do know that f of x is the square root of x minus 6. So just write it down here again. F of x is the square root of x minus 6. So f of 15 is going to be the square root of 15 minus 6, and the square root of 15 minus 6 is the same as the square root of 9, and the square root of 9 is equal to 3. Okay, the next bit is a little bit difficult to understand because it's a little bit abstract, but it's similar to the idea here. G of 2 is equal to 7 means if we put in an x value of 2, G of 2 comes out as 7, remember from the graph. And now sort of doing this the other way around, G of x is equal to something, and the solution to that is x is equal to 1. In other words, when x is 1, if we go up to the graph like this, we end up with a number here, and then we go across. So in other words, we're saying g of x is equal to 12. So the equation really that we're solving is g of x is equal to 12. Now, 1 is not the only x value which gives us a y value or a g of x value of 12. If we go across to the graph over here, this value here of x, in other words, minus 0.8, it's also true that g of minus 0.8 is equal to 12. And if we carry on across the graph this way, we can see there's another value of x which gives us g of x is equal to 12, and that is 3.8. So it's also true that g of 3.8 is equal to 12. So in other words, the other two solutions are x equals minus 0.8 and x equals 3.8. That's quite clear from the graph. Okay, let's look at the last part. This question says find an estimate for the gradient of the curve at the point where x equals 3.5. Now the gradient of the curve, the reason it's an estimate is because I'm going to work out the gradient of the curve using a tangent. In other words, I'm going to draw a straight line which goes in approximately the same direction as the curve at the point where x is equal to 3.5. Now x is equal to 3.5 here, which means that the bit of the curve that we're talking is this bit here. So we're trying to find out the gradient of the curve at this point here. Now the easiest way to find the gradient of the curve, in fact the only way to find the gradient of the curve, is, as I've said, to draw a tangent to the curve. Now that is a straight line that goes in approximately the same direction as the curve at this particular point here. Okay, so I'm just going to draw a short one first, and then I'm going to have a go at extending it. It's easier to do this with a ruler, so let's just make that a bit longer in that direction. Let's just make it a bit longer in that direction, and what I should have there is a straight line which goes in approximately the same direction as the curve at this point here. So how am I going to find the gradient of this straight line, which is the same as the gradient of the curve at this point here? Well, we know that the gradient of a curve, or the gradient of a straight line rather, so if we have a right angle triangle like this, the gradient is always going to be the vertical divided by the horizontal, or you might know it as the rise divided by the tread, or you might know it as the y difference divided by the x difference. However, what's going to happen is that we're going to have to draw a right angle triangle which fits neatly underneath here. Okay, so I'm going to go probably from about, well, let's go all the way down here. In fact, let's use the straight line. I'm going to go from here all the way over to here. It's probably the simplest way to do it. And all the way down here. The bigger I can make my right angle triangle, the better. And then I'm going to think about how far it is from here to here. Well, basically, that's 2 there. That's 4 there. So it's 2 units from there to there. On the horizontal scale, each square is 0.1, so that's easy. So I've got 0.5 there. I've got 0.5 there. Altogether then 2 plus 0.5. It's 3 units from there to there. Okay, now let's go in the vertical direction. So I'm trying to find out how many units it is from here to here. Right, again, scale is different in this case. It's 10 units from there to there. So that's another 10 from there to there. And I've now got, what's that? So 1, 2, 3, 4, 5, 6, 7, it's about 8. So altogether I've got about 28 units in a vertical direction. So the gradient, I've got 28 vertically, and I've got 3 horizontally. So the gradient is going to be approximately 28 over 3. Well, that's about 9.3. So the gradient of the curve when x is equal to 3.5 at this point here is about 9.3.